again. Same agenda and just different people that you're going to meet today. So Jamie is who's going to be doing our resume review. We have Nathan and Avik on the line, who are going to be doing our technical interview, the mock interview, and then last but not least, Adam Walkov, our resident wrapping engineer, who is here to be answering your questions in the chat, giving you some tips and tricks along the way. So let's jump in. So would love to give y'all some context with kind of where this mock technical interview sits within our recruiting process. So this is kind of the basic intern hiring process that we have at LinkedIn, just to give you an idea. So first is the application stage. Believe it or not, our roles for summer 2024 internships are going to be opening this week, and then the following weeks as well for different types of intern roles. So make sure that you're following up with any emails that your recruiter from LinkedIn is sending you, because we will have some roles for you to apply to soon, and we're so excited. So you'll apply, and if you look like a good fit for the role, then we're going to send you a HackerRank assessment, which is just something that you'll complete online. It's a 75-minute coding challenge. If that goes well, then you'll move to a recruiter phone screen, where you'll get to talk with one of the lovely people on my team or myself. And we're really just getting to know you, learning a little bit about your interests, what you're looking to accomplish within a summer internship. And then we'll move to the virtual on-site interview. So this is, it kind of depends on what role you are interviewing for. But typically it'll be a 2-hour interview. You'll have a technical module, which we'll be kind of going over today during our technical mock interview. And then you'll have a host manager module, which is usually with an engineering manager. And they'll be asking you about, it's a more behavioral interview. So they'll be asking you about your background and what you've enjoyed studying, your passion for technology or engineering. And then after you finished your virtual on-site interview comes a hiring decision. So if you have any questions about this, feel free to reach out to your recruiter, which is the person who invited you to this code-in session today, or drop a question in the chat, and we'll be sure to get it answered for you. I'll pass it over to Jamie now, who's going to do a pretty brief resume overview. Over to you.
Hello, everybody. Thank you, Edith. Yes, like she said, we're just going to be taking a look at an example of a resume. This is a resume of a past intern that ended up getting a full-time conversion offer, which I know is on all y'all's mind. So just to give you kind of like a guideline of a resume that looks really nice to a recruiter's eye, on this one, you can see he has up top his main skills listed. We kind of look at this first just to see if it aligns with the type of technologies you would be using in the roles that we're recruiting for. So it's always important to have those listed. Obviously, non-technical skills are awesome to have on there too. Like they have communication skills, online platforms, stuff like that. And then your coursework is also really, really important. Sometimes there are managers and teams that are looking for students that are kind of in a specific area of study. So in this one, you can see that they were an introduction to algorithm analysis. Some people have like data structures and algorithms. So any computer science courses that you've taken that you think might be relevant to roles that you're interested in, definitely have those listed as well. Underneath that, they have their work experience with their projects and involvement. On this one, they have both their professional and their personal involvement within their coursework. We like to kind of see both. If you don't have any like personal projects you worked on or anything like that, totally fine. Don't worry about it. I think when it comes to listing your projects, we just kind of like to see that you have like a specific interest, like there's kind of consistency with the courses you're taking, projects you're working on, kind of just where you're spending your time. We have the academic projects on here as well. And then one thing that you can't see on this screenshot, just because the whole resume can't fit, obviously you don't want any personal information on here, but if I had one tip of advice, it's to have on your resume and on your LinkedIn profile your expected graduation month and year. This is really important when recruiters are, sourcing and actively reaching out to people, because it tells us who is eligible for the internship, who's eligible for a possible conversion post-internship. So if you don't already have your expected graduation month and year on there, definitely make sure to add that. And I promise you it'll get your outreach will probably multiply. So just a little insider tip there. If you guys want to set up your resume like this, you're more than welcome to. Obviously, there's no one perfect way, but just kind of this key information that we went over here is what we really look for and look at when we're going over hundreds and hundreds of resumes. I'll pass it back over to Edith.
Sweet. Thank you, Jamie. Hope that was helpful, y'all. I know that when I was in school looking for internships, I always felt intimidated to create my resume because I didn't want to do it wrong or have things on there that I didn't need to. So this is a really good kind of guideline for really useful things to have on your resume. So now we'll head over to the mock interview. I know that all of you are so excited to hear from our engineers. So basically what they're going to do is give you a peek into what to expect during our interview process. Also just want to call out, I know that somebody requested to record this meeting. I am recording the meeting and it will be uploaded to our YouTube channel, and I can send that link out once it's done. But for right now, I'm going to stop sharing my screen so Avik and Nathan can take it away. Thanks, y'all.
All right, let's get started. All right. Hi, Nathan. How are you doing?
Hey, 1 second. Just opening up Zoom screen share. Hey, Avik. Really good.
Good. So I have you scheduled for a technical interview at this time for about an hour. Is this still a good time for you?
Yep, it's still a good time.
Awesome. In that case, let me share a little bit about what we're doing today. So this is the technical coding interview. We'll start with some intros, get to know each other, but the most of the time will be spent on a technical coding problem. We'll write some code, solve a problem, and then I want to reserve some time at the very end for some questions that you can ask me, get to know the company a little better. Does that sound good to you?
Yep.
Awesome. Cool. So I'll start by introducing myself. My name is Avik. I'm an engineering manager on the messaging team. And so if you've ever, received a message from a recruiter, somebody else, then you're using the product that I work on. What you see on LinkedIn.com, that's the what we call the flagship experience. But underlying that is the messaging platform, which is the part that stores and delivers messages. And that powers not only the flagship experience, but other products such as Recruiter or Sales Navigator that work a little differently than what you might be expecting. All right. So I have been at LinkedIn for almost 5 years now, but actually I'm a boomerang. I actually started here as an intern a while ago, was full-time for a few years, went to do some startups, and then came back and have been on messaging ever since. Cool. So that's a little bit about me. I would love to know a little bit about you. I went through your resume, so we don't have to go line by line, but would love to know what should I know about you?
Yeah, well, first off, what you do sounds really cool in the terms of just having working on something that's consumer facing that users use on a day-to-day basis. So that sounds exciting. But a little bit about me, just introduce myself. I'm Nathan. I attended a California state school where I studied computer science and music. I went in with the CS major chosen due to exposure I had in high school via the AP computer science classes. For me, it was one of the few classes where sort of the homework, the studying, the projects wasn't a chore. And it was just where I really enjoyed everything. I remember I'd go home, complete everything quickly, and then I'd start looking for more. And for me, that was very important. So yeah, I just love to code. I'm naturally curious in the whole sort of computer science programming languages domain, and I enjoy diving deep.
Yeah, that's awesome. I love that idea that, you want to go beyond whatever is kind of given to you and just dive into the nitty gritty. So love seeing that. Great. In that case, why don't I share some of the expectations of what we're going to be doing today. So as I said, there's going to be one technical question. The goal here is to come up with a working solution. We're not actually going to run the code, but we do want the code written out, and we can talk about it. You can write it in any language. That's totally fine. I'm going to leave it a little open-ended, so please do ask any clarifying questions. I'm here to work with you. It's like we're kind of colleagues working together on a problem together. And since we're not running the code, I don't care too much about specific APIs. Like if you think, oh, there is a standard library that does something, but you don't know the details, that's totally fine. Let's just talk through that. And I'm happy to help. And please do share your thought process so that, you don't just jump right into writing code, but you talk about what what you're thinking. How does that sound?
Sounds good. But is Python okay?
Yeah, Python is perfectly fine. Cool. All right, let's jump right in. So the problem that I'm talking about is you have an infinite stream of integers. So you can imagine some process producing one integer after another and offering it to your program, right? And what you want to do is figure out at any point, what are the top k integers that were offered to you, right? The largest k integers that you have seen so far. Yeah.
Okay.
So do you have any thoughts or questions about this?
So just to recap the question statement, like you mentioned, there's some sort of process, whether it's a log files, client connection, incoming numbers, some sort of stream that's producing just integers infinitely. And we want some sort of process that will be able to start up, filter them out, and return the top k.
Yeah, that's right.
Okay. I have a few questions, just to clarify, if that's okay with you. The first one is with regards to k. So is there any chance that k might change partway through? So is there a chance k could change from like 10 to 20 to 30, or is this sort of they let us know k in advance and that won't change?
Yeah, that's a great question. So how would your approach change based on either assumption?
So my thought here is, if there's any chance that k is changeable, the program would need to hold every number in memory, and would have to sort of recompute on change. If it's a single k that doesn't change, we'd be able to evaluate a number and know at that time if it would be needed if it's needed, and if it's not, it will be dropped and it won't be needed ever.
Got it. Yeah, that makes a lot of sense. So if you don't know the k ahead of time, it might be that you're asked for literally all the integers that you've seen so far, so you have to hold on to everything, which is, of course, pretty tough to do if there's a lot of integers. Okay, great. Then let's simplify and let's go with k that you know ahead of time, and go from there.
All right, sounds good. One more question just to clarify this further.
Absolutely.
What about duplicates? So is there a chance, do duplicates matter? Are you interested in having duplicates of the same number if that's part of the top k, or do you like to sort of omit any sort of duplicates and just have the largest unique k integers?
Yeah, absolutely. So I've seen approaches where you have to change the approach completely to handle duplicates in one way versus the other, as well as approaches where handling duplicates in one way or the other is just a small tweak to the program. So why don't we do this? You go ahead and approach it however you would like, make whichever assumption you would like. Just tell me more about it as you go through, and at the end, if it's something that we can change easily, we can talk about how we might alter it to the other way.
All right, sounds good. So I think when I approach this problem, I will keep duplicates and return duplicates as long as it's part of the top k, and we could potentially discuss changing that later.
Yeah, that sounds great.
All right, so those are the clarifying questions I had for this. Is it okay with you if I just run through one more sort of input and output example to make sure we're on the same page before I start coding?
I think that would be fantastic. Let's do that.
Sounds good. Let's throw a doc string in here.
Okay.
So let's say this program I started up, k is equal to 3. So we're interested in the top 3 integers of this stream. We receive a stream of s where, let's just say we have, or an infinite stream s, and let's say there's like 6 numbers that we've seen so far. So maybe -4, 100, 4, 5, 2000, and minus 10,000. So large string, you have some positives, you have some negative numbers. You mentioned that this is a method that can be called at any time. So I'm assuming we're going to expose some sort of class member variable or class function, class method called get top k. So let's say we've seen stream of s so far. We've processed these 6 numbers and we're calling get top of k when k is equal to 3. In this case, we would be returning 5, 100, and 2000.
Yeah, that makes sense.
And just one more thing that I'm seeing here, does it matter the order that's returned, or is it as long as it meets the criteria of top k?
I think let's keep it simple and go with whatever order. Let's see if there's any interesting order that just pops up as a result of how you approach this problem.
Okay. Sounds good. Good with you to start talking through potential approaches. There are a few different ones that I can think of.
Yeah, I think this looks good. It seems like you have a handle on what the problem is asking for. Yeah, so let's do that.
All right. Sounds good. So like I mentioned, you can think of a few approaches here. The first one is, I'm thinking, is more of just a brute force approach. First off, I think of this as a class. It's instantiated. You tell it the top k. There's like a process integer function. There's a get top k function that's exposed to the call to the users of this class. But with regards to the underlying data structures, the potential approaches, the first one is just having an underlying list. And when we process a new integer, we'd make sure that there's less than k. If there's less than k, we'd just sort of append it. If we reach the length of k, we'd sort it. And for every new variable incoming, because we have a sorted array, we can just check if it's greater than the first than the first index, 0th index. And if it is, we can swap it and call sort. So in this case, an insertion would be n log of n for the sorting, and it would be constant time to return the top k.
Got it. And in this case, what is n?
N would be sort of the max k that we're trying to process.
Got it. So we could replace n with k in this analysis, right?
Yeah.
Okay. So k log k for the insertion and constant time for the querying.
Yep.
Okay. Yeah, that makes sense. I am curious, so this works very well when you have, some insertions and then you're querying a lot because the querying is very fast. Curious, what if we had the opposite approach where, we're inserting a lot and then only occasionally querying, would your approach change at all, or how can we handle that scenario?
Yeah, so I don't think that the query will change at all. I think the query will always be constant time O of 1, since we're just sort of returning what's been stored. But in terms of optimizing for insertion, I can think of an optimization that would bring it to O of 2n, sort of finding it where the number would belong in a sorted array, swapping it, and then running some shift offsets. The other one I can think of would be log of k. Insertion.
Okay.
Which one would you like to hear more about?
Yeah, I'm very curious about that log of k because that's quite a dramatic improvement.
Yeah. So for the log of k insertion, I would be thinking about using a heap, such that we have a min heap. Due to the way the heaps are set up, we could check the first index 0. And if it's greater, we could sort of just run a sift down operation, insert it into the heap, and that would just slowly sort of bubble it down until it finds a spot that it belongs into, and would make sure that that heap stays at size k. And just return the underlying array when the get top K is called.
Okay. Yeah. So fundamentally, the algorithm is not changing significantly. You're still storing the top K, just using a heap instead of a list in this case to make the insertion actually more efficient.
Yep.
Right. Okay. Yeah, that sounds very promising. Why don't we go with that approach?
Okay. So I know that there's a heapq Python library. It's been a while since I've used that. Is it okay if I sort of quickly open up a man page for that, or sort of take a look at the docs?
I think since we're not running the code, why don't you go ahead and just tell me what are the methods that you're expecting to see on it, and we can just go with that. It doesn't have to be what's actually in the standard library.
All right, yeah, sounds good. In terms of the methods that I'm expecting to use, there's sort of the heap push method that will run that sift down operation where it'll sort of check the first index and see if it meets the criteria, if it's less than or greater than the 2n and 2n plus 1 offsets. And then there's the sift up where it's the removal operation and sort of the bottom up removal for the heap. So I'd only be using the two methods on it.
I think that's totally reasonable.
Heap push and heap pop.
Okay, yeah, I think that's totally reasonable. Let's go with those two.
All right, sounds good. So I'll start with the class, the overall structure, and then we'll go from there if that sounds good with you.
Yeah, let's do it.
So I'll call this class, I mentioned class because I sort of think of this here as sort of instantiating the class. You're passing it some stream, or instantiating a class, you're passing it the K, and you're as well as providing it with a stream. So I'll say integer stream filter.
Okay.
Because this is a class, we need a constructor function. So just init self, we'll come back, fill this in later after we've created the methods pass. Like I mentioned, oops, wrong language, get K largest. I don't think this function would need anything in terms of arguments, since this is just sort of returning the underlying data structure that we're processing within this class. So I'll come through and just no arguments here. I'll say pass. One of the items I like to do, I know it's not enforced in Python, is I think of this as sort of an exported function in Golang. This is the way it works in some other languages, so I made it capitalized. And then I'll just call this process streaming integer. And just pass it enough. So this is the structure I'd see, just sort of two functions here. One more internal and external facing function, and of course the constructor. I believe the constructor, what we need here is the user to pass us the top K that would be sort of filtering at and looking for. So I'd come through and say K. In this case, say self dot underscore K is equal to K. And then we need, and because we need K to know like the top K to track. And then the other data structure sort of variable we'd need is just an array. So I'd say top K integers is equal to an underlying array.
Okay, got it. You said that you wanted to use a heap, but here it seems like you're using an array. Which one are we actually ending up using?
So in this case, the heap libraries and sort of the way these are implemented is that you have an underlying data structure as an array, and sort of the heap is the abstraction on top. So when I'm using these STL libraries for the heap, I go ahead and I pass in an array, this array with every single call, and it will sort of perform the operations on the array and maintain the heap variant.
That makes perfect sense. Okay.
Cool. Get K largest. This is simple, as I mentioned. Whatever this array slash heap is, we just come through and return it. And I think sort of the meat of the question would be in process streaming integer.
Yep. Yeah, makes sense.
Cool. So talking through, we have two cases here. The first case is we don't have K integer stored. And in that case, we don't want to do any comparisons. We don't want to do anything. We just want to go ahead and insert this in our heap. So we build out the heap to K, and then we'll start being picky about what's coming in. If we already have K, we'll be picky about what's coming in. We'll check the first value like I previously discussed and either drop it in it forever or insert it into the heap. So I'll sort of say if the current number is greater than or equal to self.k.
Mm-hmm.
This is we have be picky. Else, we just want to go ahead and insert this into the heap. So insert this into the heap. I'll go ahead and I mentioned heap Q. Oh, cool. So in this case, I'll say heap Q dot heap push. I will say self dot top K integers, and I'll come through and oops, I'll just say incoming integer, and we'll go ahead. Oh, just didn't have a statement under the expression. Okay, yeah. So in this case, I just come through and we just sort of add this to the heap. Otherwise, we'd want to come through and look at the smallest value of the heap. And due to the nature of the heap, the first value would be the smallest. And then it's sort of the 2n plus 1. So let's say smallest value in heap is equal to self dot top K integers of 0, the first value. And in this case, I just say if this is bigger, if incoming integer is bigger than smallest heap value, we'd want to insert this. And when inserting this, we can't go ahead and just insert this. We also have to remove a value. Otherwise, we'll just sort of continue growing. So what I'll say is I'll say heap Q dot heap pop. So we'll run the sift down operation, sort of pull an integer from the back and move it up. I'll say self dot top integers, remove that. And then I'll say heap push on the incoming integer.
Yeah. Okay. Got it. Okay. Yeah, this looks promising. Yeah, it looks like it's. Yeah. Why don't we? Is that it for the algorithm, or is there anything else that's missing that you want to talk about?
I think so, but I'd like to run through it with a few examples, if that's all right with you. I'm just to sort of provide some examples, make sure the logic is sound, and then discuss it further.
Okay, yeah, I think that would be a great idea. Let's do that.
All right, sounds good. So in this case, I'll just create a top K filter. This is integer string filter, and let's say K is 3. Keep it simple, keep it quick, just have a few run throughs. In this case, we'll have on this class, we'll say top K filter, and just copy and paste this a few times, call it 4 times. And let's say the first item, we call this with a 1. So in this case, we come in, it would push it on the heap, the underlying heap would be 1. Come through with a 2, through, still it's not 3, or it would come through and it just doesn't match, so 1, 2. 3. In this case, it comes through and it says the current length 2 is not greater than or equal to 3. Just go ahead and insert that into the heap. And let's say we come through with a now negative number. And in this case, it'll hit the first one. Our current length of the array is 3. 3 is greater than or equal to the K. And it'll look at the smallest value in the heap, which is 1. And it'll say is if this is greater than 1, insert it. But in this case, minus 100, it's not. This is not the top K, so it'll drop the minus 100 forever. The heap will remain. And let's say I come through and I call get K largest. What would be returned is 1, 2, and 3. Looks like, or I haven't. Is it okay if I run one more example with a larger number just to verify?
Yeah, I think that would be the right thing to do here. Yeah.
So we would call get K largest there, and that's what it would return. Get top K filter dot process trimming integer. Let's say 5. In this case, 2, 3, 5 after the pop and the push, and get K largest. Or sorry, I skipped over that. 5 is greater than the smallest value in the heap, which is 1. So we would come through, would pop, would see 2, 3, and then would insert 5 would get moved to the bottom. We'd call get k largest, which would come through and return
Yeah,
the 235.
that makes sense. So in this case, we had scenarios where we were inserting something that was smaller than everything or larger than everything. How about something in the middle, just so that we kind of cover all our bases? Might have to make some modifications to the numbers that we're working with here.
Like when you say something in the middle, are you looking for a duplicate or are you looking for just maybe like 4?
Yeah, I think 4 actually would be a really good one to start with. And then maybe we can just talk about the duplicate scenario after that.
Sounds good. A little cold.
No worries.
Cool. So yeah, let's come through. Top K filter, in this case, process streaming integer 4. Is the underlying heap. In this case, would come through here. We'd say that smallest integer is 2, we're inserting 4, it's greater. We would pop the value off of the heap. The new heap would be 3, 5. And then we would call the heap push. That would give us either 3, 5, 4 or 3, 4, 5, depending on how it's implemented.
Yeah, either way, what we wanted is what happened. We ended up with only the top 3 integers.
Yep.
Yeah. Okay. Yeah. And then since we talked about duplicates in the beginning, what is the behavior here for duplicates?
If the duplicate is, if the duplicate is part of the top K, it'll keep them. If you start out, we provide it with 3 1s with the top K of 3, it'll store those 3 1s. And then if you provide it with 5, 5, 5, those 3 1s will get replaced by 5, 5, 5.
Gotcha. Yep. Okay.
Oh,
I think
my bad. Greater. Oh yeah. Yep.
Yeah. No, I think. Well, actually, yeah. Why don't we run through an example? Let's just do that real quick, just to make sure we got that right.
Okay.
Yeah. Let's say we have 1, 1, 1.
So in this case, we have 1, 1, 1 inserted. And we're not going through any of this because we're less. So we're just sort of popping in the 1. Now we want to come through and insert the 5.
Let's insert a 1 again. What happens this time?
In terms of looking to insert a 1, it would silently drop it because of the case is the current smallest integer is 1 and the incoming in 1 is
okay.
1.
Cool. And then if you were to insert the 5.
In terms of inserting the 5 would come through, would say that the incoming integer greater, and it would push the 5 to the back. We want to insert a 5 again. It would still see that 1 is the smallest number, push the 5 back.
Yep.
I want to insert the.
Okay.
Yeah.
Great. Okay. So I'm convinced. Yeah. We'll just keep around a bunch of the duplicates. Nice. Okay. Cool. So yeah, we already talked about some of the runtime of this. So let's just say if we had n integers is how many we've seen so far, like total, right? And you're keeping the top K. How many out of all the insertions that you've done, how much time does that take total?
Yeah, well, the size of the heap in this case is maximum K. So it would be n operations, n log K operations, so n log K.
Yeah, okay. And then how much memory are you using? What's the space complexity?
Oh, in this case, it would just be O of K, where K is just sort of the length of the array.
Yep, okay. So in particular, it's not O of N, which is important.
Yeah.
Right. Okay, Great. Okay, I think in that case, that covers everything I wanted to go over. I wanted to reserve some time for you to ask me any questions. So yeah, what can I answer for you?
Yeah, so one of the things I'm really interested in is the tech stack at LinkedIn. I'm really familiar with React, Python, Golang, a little bit of Java, but that's about it. I'm sort of curious, like what LinkedIn is built on and what you use specifically within your team.
Yeah, absolutely. So at LinkedIn, we do use a lot of standard technology. So depends on which part of the tech stack we're talking about, but server side will be Java using a framework called Play, and then we have web using like JavaScript, some TypeScript as well, a framework called Ember, which is open source. For Android and iOS, you have the respective like Java, Kotlin, Objective-C, and Swift, some mixture of those. So yeah, a lot of standard technologies what you would expect for these different platforms.
Yeah.
Cool. Yeah. Any other questions?
I guess, yeah, if there's time. One other item that sort of was interested, you mentioned you were an intern at LinkedIn. You were at LinkedIn for 5 years. You left and you came back, correct?
Yes, that's correct.
What was the reason for leaving and then, I guess, boomeranging back?
Yeah, absolutely. So when I left, it's not that I was unhappy at LinkedIn. I was actually, enjoying the work that I was doing. I felt like I had gotten a really good foundation because of the structured processes that we have at LinkedIn to help people learn and become better engineers. And then I wanted to go and do some of the things that kind of, I would not have a chance to do here. Obviously, learning from like product and other roles was there, but at a startup, I got to actually be in those roles and understand about like product market fit and talking directly with customers, that type of thing. So even though I was kind of sometimes cutting back on my technical growth, I wanted to just expand my mind. And when it was time, when those startups didn't exactly work out the way I wanted to continue my journey back at LinkedIn and apply all those things that I learned to this new role. Yeah.
Cool.
Awesome. Cool. All right, then. Thank you so much for taking this time. It's been wonderful talking with you, and enjoy the rest of your day.
Thank you, Avik.